Hello everyone, welcome to another kinetic tutoring episode, and today we're going to be talking about how to solve an acceleration equation using both forces and torque. So let's get right into the problem. Alright, so the prompt reads, a uniform solid cylindrical log begins rolling without slipping down a ramp that rises 28 degrees above the horizontal. After it has rolled 4.2 meters along the ramp, what is the magnitude of linear acceleration of its center of mass? Alright, so what we're looking for in this problem is linear acceleration, which is just a of the ball. So the first thing we're going to want to do is draw the ball on the ramp and sort of make a free body diagram of all the forces acting on it. Here we have the center of mass of the ball. So we know that there's a gravitational force going straight down. We know that there's a normal force going this way. And we know that there's a friction force. I misdrew this because the normal force is going to be acting on the ball right here where the ball is touching the floor. And it's going to be perpendicular to this line right here. And we also have the friction force, which is also going to be applied at the same point and goes against the direction of the ball. So the way that we're going to solve this problem is by comparing our torque equation for the ball to our force equation for the ball. So let's write out our force equations first. So here we have the horizontal component, which is up and down the ramp. MA is equal to, and we have a horizontal force here of gravity. If we check out this here, here's our horizontal force, which is going to be the force of gravity times the sine of this angle here. And in the opposite direction, we have friction. So we could just write minus F. And then we have to consider the horizontal component, and since the ball isn't going up and down horizontally, it's staying on the ramp, we know that the acceleration is 0. And we have the other component of gravity, which is mg cosine theta, going down, and we have normal force going up. So from this we can concur that our normal force is going to be mg cosine theta, and we know that friction is just mu mg cosine theta, so we can plug that into our equation here, and we'll get that ma is equal to mg sine theta minus mu mg cos theta. And from here we get an equation for acceleration, seeing as how we can cross out all the m's, and our a will be g sine theta minus mu g cosine theta. Now we still have a couple unknowns here, such as the acceleration and the coefficient of friction. So what we're going to do next is look at the torque equation, which is I alpha is equal to force times radius. And here when we look at the three forces acting on the ball, the gravity is not going to provide a torque because the angle it is creating is 180 degrees. Same with the normal force, and meaning that the only force that is going to apply a torque is the friction. So we write out the friction force, which is just mu mg cosine theta, and we multiply it by the place where it is affecting the ball, which is at radius r. And so since the ball is not slipping, or rather the log is not slipping, our alpha can be rewritten as a over r, and the inertia of a log is 1/2 mr squared, so we can write that out. And what we will see here is that all r's cancel, so we can just cross out all of these r's, and we're left with 1/2 ma is equal to mu mg cosine theta. And we could get rid of the m here, move the 1/2 to the other side, and we will get that a is equal to 2 sorry, I accidentally wrote the m there, 2 mu g cosine theta. And now let me make some room here so we can finish our problem. Alright, so now we have two equations for gravity, we have two equations for acceleration rather, so we can set them equal to each other. G sine theta minus mu g cosine theta, which we have here, is equal to 2 mu g cosine theta. And add the mu g cosine theta over to this side, we'll get g sine theta is equal to 3 mu g cosine theta. We can get rid of our g's, and sine theta is 3 mu cosine theta, and that will give our mu a value of 1/3 tangent theta. And what I did to achieve that value was divide both sides by 3 cos theta. 1/3 sine over cosine will give you 1/3 tan theta. And from here we can just go back to our acceleration equation here. A is 2 mu g cos theta. So we can just plug in our mu. A is equal to 2 times 1/3. We're going to write out the tan theta as sine over cosine g cos theta. As you can see here, the cosine on the numerator and the cosine on the denominator cancel, so we'll get 2/3 sine theta g. Let's make some more room. Or actually, I'm going to erase this entire board. Just keep in mind that acceleration is 2/3 sine theta g. Let me rewrite that, 2/3 sine theta g. And from here, it's just a matter of plugging this into your calculator. Sine theta is sine of 28 degrees times g, which is roughly 9.8. So let's plug this in to see what we get. Sine of 28 degrees is somewhere around 4.7 times 2/3 is somewhere around 3.1 times 9.8 gives you a number around 3.067. Alright, and that's how you solve that problem, guys. You'll get an acceleration of 3.067. Make sure to remember that your units is meters per second squared. And that's all I have for this video. Make sure to tune in later for more physics tutorials.